As we continue on with Lesson 38-1, Section 2 this time, we'll be covering Question 3 only. On the previous two slides, you should have first seen the paragraph that follows. Just as the mean and standard deviation are used to describe center and variability in the data set, there is a summary statistic to describe the strength, or how close the points are to a line, and the direction, positive or negative, of a linear relationship. This statistic is called correlation coefficient and is denoted by the letter R. Then there was a slide that contained a couple of math terms. Two numerical variables are correlated if one variable tends to increase or decrease as the other variable increases. Next math term. The correlation coefficient is a measure of the strength and direction of a linear relationship. The correlation coefficient is denoted by the letter R. Math tip. Variables are positively related if lesser values of one variable tend to occur with lesser values of the other variable. Variables are negatively related if lesser values of one variable tend to occur with greater values of the other variable. What we're going to be looking at is we're going to be looking at question 3. Now, 3 covers 2 separate pages. It starts on page 560, it ends on page 561. So let's take a look. It says, given below are 7 scatter plots and 7 verbal descriptions of relationships. Match each scatter plot with the appropriate description. Each scatter plot goes with one and only one description. Right. So we're going to take a look at this. Let's go back over here. I'm on top of page 561 and I'm looking at these statements. It says we have a very strong positive linear relationship. We have a relatively strong positive linear relationship. And we have a relatively weak positive linear relationship. And notice that this R was 0.981. This one was 0.828. This one was 0.310. D says very slight or no linear relationship. And look at your R, 0.043. E says relatively weak negative linear relationship, negative 0.238. Relatively strong negative linear relationship, and there should be an edit here. This should say R equals negative 0.772. And here we have a very strong negative linear relationship. This one's negative 0.95. Notice that the ones that contain the negatives also had a negative linear relationship. The ones that were positives had a positive linear relationship. Keep that in mind. That's going to be important. So I'm looking for a very strong positive linear relationship. Okay? Strong positive. Well, this is clearly positive. I'm not going to say it's strong, but it's positive. Okay? This one's definitely negative. Not strong, but negative nonetheless, because it looks like it's going downward. Okay? Here I've got a very strong negative. And on this plot 7, I've got a very positive, very strong positive here. So we're going to start off with saying which one of these has a very strong positive linear relationship? Well, we know it can't be this one because it's negative. We know that it can't be scatter plot 5 because it's negative. And if you look at 3, 4, and 6, they all look like they're very weak in whatever they have decided. Okay? So I'm going to say that it's either scatter plot 7 or scatter plot 2. Which one of those is stronger than the other, meaning that it forms a very distinct line? Well, clearly that would be scatter plot number 7. Now it said, remember that these match one and only one. So that means I know I cannot use, we cannot use scatter plot 7 again. We've already used it. Okay, let's take a look at the next statement. This one says relatively strong positive linear. Okay, so I'm looking for one that's very defined as a positive, but not very, very strong. It's kind of relatively strong. Well, hopefully you've eliminated 1 and 5. And if we recall, 3, 4, and 6 weren't as defined in their line. So I would say that our relatively strong one is scatter plot number 2. Now again, recall we cannot use them again. Now I've clearly identified 2 negatives that I can clearly see, 1 and 5. Of those 2, which one would you say is the stronger linear relationship? I agree. I think it's scatter plot 5 is stronger. So I'm looking for strong negative. Well, strong negative is G, so we're going to say that was scatter plot 5. Our other negative that we could clearly define was scatter plot 1, but this one's not as strong of a negative slope. So this is going to be our relatively strong negative. So that's number 1. So that leaves me with 3, 4, 6. 3, 4, and 6. Let's take a look. Would you say that 3 is more positive, more negative, or neither? Would you say 4 is more positive, negative, or neither? And would you say 6 is more positive, negative, or neither? The way I identify these is I look. Okay, let's look at some points. Here, I have some points that are at the upper end here. And I have some points that are kind of even. So if I had to kind of look at this, I'm not seeing any type of strong negative or positive here. So I would actually say that this is the one that has very slight or no linear data at all. So that would be letter D. I'd call this number 3. Okay, now we're down to 4 and 6. One of those is going to be a weak positive. The other one is a weak negative. Well, if we look at these values here, I'm picking out a few points in particular. I got this point here, and I got some points here. And if I tried to connect those points, it would be something along those lines. Not exact, but it's going more this direction. So that would be considered negative. So I would say that this is E. Number 6 is E. Same thing here. We have some points here, and I have points that are up this way. So if I try to connect or go in that direction, it's more of an upward slant. So this would be scatter plot number 4. So on 3, I have the following: 7, 2, 4, 3, 6, 1, and 5. On to your debriefing question.